That's the functional group analysis. 1700, 1300, 1200, 1500, and so on, or 3000. It tells you what functional groups there are in that molecule. Less than this, you really don't get much functional group information. Because what happens is when you go to the lower end, if you will see, every molecule in that, every group in that molecule will somehow be taking part in that. So if you have a large molecule and you look at a vibration that's occurring, let us say at 600 wave numbers, something will happen at one end, something will happen at the other end. You really can't pin it down to a functional group really. It looks like the entire molecule is engaging in a big dance. And therefore we call that region as vibrations that actually incorporates the entire skeleton of the molecule. And we call it as skeletal vibrations. You can't pin it down to a given functional group. It's got to do with the entire molecule. It's called the skeletal vibrations. Is that useful or not? Well, on the face of it, not. Because if it doesn't give me functional group information, what do I really do with it? It's extremely useful. Because, let's say if I gave you some natural product. Let's say you are working in the forensic laboratory and the police came and said, here is something that we have just found that we have contraband drug and I want you to see whether this is some narcotic. Let us say it is cocaine. Can you figure it out for me whether it's cocaine? How do I do it? Take cocaine. I mean, not internally. Take cocaine and record a spectrum. And then take this material that the police has given you and record a spectrum. Functional groups won't tell me a thing. Because functional groups at 1700, every molecule containing a carbon will show me there. So the functional group now is of no use to me. I have been asked to make an identification of a molecule. What do? I go to the skeletal region. The skeletal region actually is so unique to that molecule because it's got to do with the entire molecular skeleton. And therefore, if I have this unknown molecule and my suspected molecule, I record a spectrum and make a match, and if it matches bang on, then I know what this molecule is. So the skeletal region actually is extremely good for making these comparisons. So if you're asked a question, is this molecule A? Is this molecule nitrobenzene? Or is this molecule something that is suspected to be? All you have to do is to take that molecule, record a spectrum, and compare that with the skeletal region. Because the skeletal region is very complicated, but it's very unique to that molecule. So if these two spectra match, bang on, then you know that you are really looking at the molecule in question. If they don't match, then you know that's not what it is. Actually, generally in science, if it doesn't match, then we say it does not match. If it matches, we say it is probably the same. Because who knows, there might be some other compound, with very close line spectra, and therefore it could be a match. So you always guard yourself against such eventualities, and you say if it does not match, it does not match. It is not B. If it matches, well, it is most probably B. So that you guard yourself against any possible liabilities later. So that's basically the skeletal region and the functional group region. What I will do for you is I'll give you a bunch of spectra and I'll send it to you the name. And what I would like you to do is look at the spectra and be able to judge whether this molecule has a carbon in it or whether it is this. Or what I could even do is to give you, and this is what I will do in an exam. I will probably give you a bunch of molecules and a bunch of spectra. And what you have to do is actually make a match. This spectra should belong to this molecule and this spectra should belong to this molecule and so on. And that's basically what you have to do. I'm not asking you to look at a spectra and come out with the actual assignment from an infinite number of compounds, which is what is going to happen in real life. Nobody gives you a spectra and a bunch of possibilities. You have to figure out what it is. But in an exam, what I will do is I'll give you a bunch of spectra and a list of compounds. And as usual, if I have 5 spectra, I'll give you 10 compounds. So which essentially means that only 5 of them are right. And you have to make a match of which one is which and be able to tell me what the compound is. And the way you would go about doing that is actually by looking at the functional group, looking at the possibilities, and then come up with the assignments. So that's what we will do. So we will look at this a little more because I need to tell you something about attenuated total reflection, which is what the experiment that you already have done. we will discuss that a little bit as to how it works and how that is used to record all these spectra. And then maybe I will move on to Raman. What I will do this time, this module is because I will give you the papers now, and as you will see, they kept saying we have to improve on our numerical ability, start making less errors overall. So what I will do is from now on, the tutorials, I will give you a bunch of assignments, call you over tutorials one day, and handle another set of assignments based on what was given at home. You will have to do it right there and give it to me. I know I'm killing myself because I then have to evaluate another 120 things, but I'm willing to do that because I find you just need practice, and maybe many of you are not really going through the whole process of actually completing the problem right to the very end, and that's the reason why this is happening. I'm sure all of you are far more capable of what I'm seeing, and I just need much better performance than what I've seen here. It could be both ways, maybe you didn't do well and maybe I didn't do well, I don't know. But the thing is, we just have to do much better than this. But I will use the tutorials this time a little differently, not come in and just do problems. I will give you another set of problems for you to do. You will have to do it in class, turn it in, and then I will grade them for you. I think at least you will catch where your problems are well before the examination. So sorry about it. Still time, because we still have one more mid-sem and one end-sem, which is another 80 marks up for grabs. So this is only 20. But I wish both of us do much better in the next exam. Okay, I will pass on the papers now.